we're going to get our session started. So at JPL, they're already playing with their pop flies. So good morning, everyone. Welcome. Thank you all for participating in our third annual Discovery and New Frontiers Educator Workshop. We've gone from the thrill of discovery 2 years ago to a vision of discovery last year, and now the challenge of discovery. We've got a really nice workshop planned for you, some great speakers, some new and exciting activities. So I'm Shari Asplund here at the Jet Propulsion Laboratory, where we have about 75 people or so. And I want to welcome our colleagues at the Johnson Space Center, at the University of Arizona in Tucson, and at the Applied Physics Lab in Laurel, Maryland. So thank you all. What I thought I would do is to step back just a little bit in history and take a minute to really think about and appreciate where we've come in space exploration. Good old Galileo there, holding his tiny little telescope. In 1610, he discovered Jupiter's moons. That was the drawing that he made, because even Galileo realized that science isn't finished until it's shared. So this is his way of sharing what he discovered with his colleagues at the time. And what he found changed history. 4 moons around the planet Jupiter. Fast forward about 400 years or so, new and better telescopes allow discoveries of more and more planets, their moons, asteroids, comets, but from very, very far away, little tiny specks of light. The first spacecraft to reach another celestial object, the one I've got showing there, Luna 2, was a Soviet spacecraft that went to the moon and impacted it in 1959. But in 1962 is when planetary exploration really began. NASA went to Venus with the Mariner 2, the first successful interplanetary flyby. After that, there were a number of flyby missions to Mars, to Jupiter, to Mercury, Saturn, onto Uranus, and then Neptune. Voyager 2, and here at JPL, we've got a model of the Voyager spacecraft. I believe it's a full-size scale model of Voyager. And amazingly, the 2 Voyagers are still flying. We're still collecting data from them. I don't know if you've heard it in the news recently, but there has been some speculation that Voyager has finally left the influence of our solar system. But the NASA science team here at JPL, led by Dr. Ed Stone, who's been the project scientist since day one. He's a former director of JPL and just a dear, wonderful man. He has said that it's the consensus of the Voyager team that Voyager has not yet left the solar system or reached interstellar space. In December 2012, the Voyager science team reported that Voyager 1 is within a new region called the magnetic highway, where energetic particles change dramatically. A change in the direction of the magnetic field is the last critical indicator of reaching interstellar space, and that has not yet been observed. But this amazing spacecraft is so far away and still sending signals to us. So wouldn't Galileo have been blown away by the images that Voyager and some of the other spacecraft have returned to us? Those are those same 4 moons, but now we know that there's volcanoes, that there's frozen ice, that there's all kinds of impact craters. We've learned so much from what we have been able to explore. And it's really fascinating to be living in this time frame. It's only been in the last 45 years or so that humans have been able to look up and know what some of those objects they're looking at actually looks like. For thousands of years, people could only dream and wonder. So when it comes to planetary science, it's really still all about the questions, the basic ones of where do we come from, where are we going, and are we alone? And in the Discovery and New Frontiers programs, the ones that are sponsoring our workshop today, those are lower cost planetary science missions that are searching for answers to those questions in a variety of different ways. What they're finding is revolutionizing our perceptions and challenging long-held theories with amazing new images, fantastic data, and samples. Each of these missions is proposed by a principal investigator who puts together a large team of scientists and engineers who have to work together and communicate. And that's really so key, because scientists, there might be 50 scientists or more on a science team, but they have different areas of expertise, and they have to be able to communicate well with each other. Narrow fields of focus don't necessarily mean that I understand your science or that you understand mine, so they have to be able to talk to each other. And they have to be able to talk to the engineers, because unless the engineers can understand what they want to, where they want to go and what they want to do, it won't happen. And you know what? Engineers and scientists kind of speak a whole different language. So it is so crucial that everyone can communicate well among these large teams, and then again communicate it to the public. So the scientists are basically people with lots and lots of questions on a quest for new knowledge. The picture that I've given you was a proposed mission that didn't get funded. Some very curious scientists wanted to send this kind of boat-like thing to one of the methane lakes on the moon Titan. And it didn't get funded, but it might in the future. Who knows? We might someday have a boat floating on one of those methane lakes and find out what that's all about. And I've included this quote from Albert Einstein because I thought it just seemed so appropriate. Raising new questions and new possibilities, looking at old problems from a new angle requires creative imagination, and that's where the real advances in science come from. The creativity, the ability to look at things in a completely different way. The things that some of your students might think they're a little weird for, but it really is what makes them so special, and future scientists. So each mission has hundreds, literally hundreds and hundreds of people that are needed to formulate the science questions, build the machines, come up with the trajectories, develop software, program the sequences into the computers, create graphics and animations. And that's the New Horizons team, and just a partial view of them. Just the group that happened to show up for that particular meeting. So it is literally hundreds and hundreds of people, which means many, many opportunities for your students, no matter what their interests may be. So this is a brief overview of the Discovery missions that I know you can't see, but I just wanted to give you an idea of the breadth and the number of missions since the program started in 1992, with flybys, orbiters, landers, rovers, an impactor, just really the entire gamut of the different ways that NASA explores the solar system. So these missions are all coming back with breakthrough science, and it seems that most of these people tend to wear shower caps a lot in public. So I just was looking through some pictures, and I found some ones that I thought might be interesting. So we're just going to go look at a few of them. This is the Grail spacecraft being assembled at the Kennedy Space Center, getting ready for launch. This is the Deep Impact Instrument team, getting ready to get theirs packed and underway a few years ago. Vibration testing on the Messenger spacecraft. There's no shower caps in this one, but I thought it was really cool pictures. That's the New Horizons spacecraft, which is on its way to Pluto. That's the way it looked when it was about to be enclosed in the fairing on the left, and then after it was in the fairing on the right. You get a bit of the size of the scale with the person there. And see, that's about to be then put on the top of a rocket and to be sent on its way to Pluto on a 9-year journey. So the Discovery missions have had NASA's first sample returns since the Apollo days when the moon rocks were returned. The Stardust mission collected and returned dust from a comet called Bilt 2 back in 2006. And the Genesis mission captured and returned ions of solar wind in 2004. And I love the picture on the right of Genesis because you can see the tiny, teeny people at the bottom and really get a scale of the size of the spacecraft with the payload at the very top. So Genesis during assembly, this to me looked like something out of a 1950 science fiction movie. They look like they're just kind of hanging there, getting ready to get the thing finally assembled. The Genesis mission, and I don't know if any of you might recall it, but it had a very hard landing. It was supposed to have an extremely soft landing under parachute and picked up by a helicopter. The parachutes never deployed. So they had 15,000 small pieces. So the scientists, in their shower caps, had a whole lot more work to do than they had planned. But they planned for that contingency. They had tweezers and buckets, and they picked up all those pieces. And the science gathering took a lot longer than they had thought, but they are getting the science. They're finding the answers to the questions that they had posed, which were about what is the sun made of? What are the chemical elements and isotopes that the sun is made out of? And they're getting information. The woman on the bottom right in the blue, Karen McNamara, you're going to be hearing from her a little later today, talking about what exactly goes into sample return. Here we've got the Stardust spacecraft about to be shut in its big container and sent off. That was the Stardust ground recovery team. Both Stardust and Genesis came back to the Utah test and training range. And obviously you can imagine the challenges involved with that, with bringing them back safely and picking them up and making all the plans. And that's the size of the sample return capsule. It's so small to think about how far it had traveled, over 4 billion miles total, and coming back to land in Utah. And that was when they were first opening it up for the first time, not knowing, not having a clue what they were going to find inside. They found what they wanted. V for victory. That was the very first views that they had of the comet dust, actually embedded in the aerogel collectors. So some of the other missions, just briefly, that I wanted to talk about, Grail. The Grail mission just ended in December. It was twin spacecraft that were called Ebb and Flow that generated the highest resolution gravity map of any celestial body. It measured the gravity of our moon. The goal was to provide a better understanding of how the Earth and the other rocky planets in the solar system formed by getting all the information they would get about our moon. Both probes were directed into the lunar surface in December as it was running out of fuel. The landing site was named after Sally Ride. Sally Ride Science was the education partner for the Grail mission with a project called MoonCam. So these are the Grail twins being prepared to ship to the Kennedy Space Center. So what are the challenges for a twin spacecraft? Obviously, you have to build two of everything. And they had to speak to each other from very close distance and very good range. So there were a lot of challenges involved with actually making that work. This is the NASA Deputy Administrator Lori Garver touring the Astrotech Payload Processing Facility. Back to those shower caps. This picture are the fourth graders from Bozeman, Montana, who named the spacecraft. There was a contest, and they were pretty thrilled to be the ones whose names were selected. And these are actually maps of the gravity, showing the gradients measured by Grail. The red and the blue indicate stronger gradients due to underlying mass anomalies, which in the future will give future spacecraft a really good idea of where not to land, where not to set their target. Spacecraft have crashed, about a dozen of them, on the surface of the moon because of that unusual gravity tug. So this will be extremely helpful for that and for other things. InSight is the newest mission selected into the Discovery program just last August. It's going to place a geophysical lander on the surface of Mars to study its deep interior, giving this insight into the processes that shaped the formation of the rocky solar system planets. The plan is for it to launch in March of 2016. It'll arrive at Mars about 6 months later and conduct science operations for about 2 years. Challenges for InSight. Well, it's been a real challenge for the scientist who's in charge of it, Bruce Bannert, here at JPL. He's been trying to do a mission like this for years. And he actually had this as an instrument on a French mission about 10 years ago, and then that mission got canceled. So he's persisted, and finally his plan to dig deep beneath the surface of Mars is funded and is being built right now. We've had these wonderful rovers on the surface of Mars now for a while, but we've never gone below the surface, and that's what the goal of this mission is. So comparing asteroids. The Dawn mission spent a full year in orbit around Vesta, and now it is moving onward to Ceres for a very close-up comparison of these two very large and very different asteroid belt objects. So this is a view of Vesta from the Hubble Space Telescope back in 2007. Up to that point, it's the best view we had. Not very good, pretty blurry, no features. This is one of our best views now. It's a compilation, and the colors are used to show differences in minerals. So you can see the bright orange and reds near that crater, totally different from what we see at the South Pole. The South Pole is a huge mountain that's larger than Mount Everest. So colorizing really helps us distinguish features. Ceres, that's the best look that we have right now of Ceres from the Hubble from 2004. So when Dawn gets there in 2015, we hopefully will have, again, more amazing, really detailed pictures. Now, Ceres is a great example of how scientists' thinking evolves over time regarding classification of objects in the solar system. Ceres was discovered in 1801 by Giuseppe Piazzi. He initially thought it was a comet, but as he observed more and more and more and saw that the movement was slow and uniform, he ultimately decided it was the 8th planet, and his colleagues at the time agreed. So for 50 years, Ceres was regarded as a planet. Suddenly then, more and more scientists started observing objects in that big, vast region between Mars and Jupiter. And they realized that that was a class of many similar type objects that they chose to call asteroids, meaning star-like. So Ceres got bumped from being a planet to being the biggest and most massive and first discovered asteroid. So that was pretty cool for Ceres for like 150 years. But then there came the International Astronomical Union's decision back in 2009. It was kind of a demotion for poor Pluto, some people think. But it was a bit of a promotion for Ceres, because Ceres went from asteroid to dwarf planet. So Ceres has been called every name in the book, basically. But Ceres doesn't care. She's just waiting for dawn to come and finally take some good pictures of her so that we can see what she really looks like. So it just kind of shows you how the more we learn, the better our tools are for observation. Things change, and they're going to keep changing. We keep finding more and more objects out there. Mercury, you're going to hear a lot more about our MESSENGER mission, which has been in orbit around Mercury now for over 2 years. One of the big challenges that the MESSENGER mission faced was being in orbit around the planet closest to the sun and also not getting sucked into the sun's gravity. But this ceramic fabric sunshade, which is about 8 feet by 6 feet tall, is on the spacecraft, and it's actually what keeps the instruments at room temperature all the time, no matter how hot or cold the planet gets. Pretty amazing. Pluto, New Horizons. We can talk and talk and talk year after year, and it's still chugging along on its way there. It launched in 2006, and it'll get there in 2015. At the bottom right, again, that's the best image we have right now of Pluto from the Hubble Space Telescope. So we're hoping to see really good details of not only Pluto, but its moons, and then on into the Kuiper Belt. And then another new-ish mission that you'll be hearing much more about today, it's another sample return, joining Genesis and Stardust in our program of sample returns, OSIRIS-REx, and you'll have to, if you don't have any other questions, ask the people there what that stands for, because I'm not going there. It'll be NASA's first asteroid sample return. It's scheduled to launch in 2016. Once it arrives at the asteroid, which has a not very good name, but there has been a naming contest in place, and the name selected should be announced. It was for students, so hopefully it'll be kind of a fun name. That should be announced, I would hope, in the next few weeks. It'll spend time mapping, measuring, and finding the ideal place to launch. And you're going to be hearing later on kind of from a member of the team who will be choosing the place where they're going to land. Actually, they're not landing. They're actually going to hover and grab a sample of soil. So how they determine where that best place will be. And then it will be back returning to Earth in 2023. And hopefully some of your students will be among the scientists that will be analyzing those first samples from an asteroid. So I can't go without plugging my Space School musical. If you haven't seen it, there's a copy of it in the CD you're getting with all your materials today, or for those of you watching on webinar, it's available on our website, discovery.nasa.gov. It's a very fun way to introduce students of all ages to the solar system. Notice how Mars is kind of spying that gas bag Uranus a little suspiciously, I don't know. This was a performance done by students from the Lemon Grove School District in San Diego at the San Diego Festival of Science and Engineering just 2 weeks ago. So the musical can be used just to watch and have fun with, and a lot of learning packed in, but we also have a whole activity guide that goes with it and a manual on how to produce the play. So the idea is the kids really get the majority of the learning experience from performing it themselves, and there's opportunities for everyone. So I would encourage you to go find Space School Musical and watch it and have fun with it with your students. So finally, our missions are doing amazing things. Every one of our missions has an education website with activities, with curriculum modules, with things for the interest of the general public. If you go to our websites, discovery.nasa.gov or newfrontiers.nasa.gov, you can link then to all of the different missions and then look for their different educational materials. There's a wealth. It's some really good stuff. And your students definitely can be part of NASA's exciting work in the future. So thank you.